I'm doing a bit of an unusual video today because the mocks are coming up and the exams are coming up as well. So I thought I might as well make a video going through a chemistry higher level paper 1 specimen paper to show how I would go about doing a paper, and then it would hopefully be useful to you guys as well. So I found a specimen paper on the internet. Starts with a title page as usual and a periodic table on the second page. And then the exercises start. So just as a warning, I don't have a lot of time to make this video, so I don't want to bother with editing too much. So if I stutter, that's just gonna be how it is. Anyways, let's start. Question 1. Which changes of state are endothermic processes? So endothermic process means that we need to add energy. The first one is condensing, and condensing is from a gas to a liquid. And this is actually exothermic. It releases energy, so it's not endothermic. Not one. Next one, melting, is going from a solid to a liquid, which is indeed endothermic. So 2 is correct. And just from this you can see that you have to take at least 2, which means that 3 must be correct. But let's just check that it is. Subliming is growing from a solid to a gas, which is also endothermic. So 2 and 3 are correct, which is number C, or letter C. Next one, question 2. What is the sum of the coefficients when the equation for the combustion of ammonia is balanced using the smallest possible whole numbers? Right, I would usually just start with writing the equation. And there's no need to add the state symbols because you wouldn't have time, because paper 1 is a bit time pressured. Right, so we see that oxygen here is isolated and so is nitrogen. But we see that we have 2 nitrogen here and 1 here, so I just start with balancing this one. Because this way we also get 6 hydrogen here, and by multiplying this by 3 we get 6 hydrogen here as well. So nitrogen and hydrogen are balanced, so we're just left with balancing oxygen. And we see that we have 3 oxygen here. So if we divide this by 2 and multiply by 3, we get 3 oxygen as well. So this is balanced now, but it's asking for whole numbers. So we have to multiply this whole thing by 2 to remove this fraction. So we get 4 ammonia plus 3 oxygen goes to 2 nitrogen plus 6 water. And if we add the coefficients, we get 4 plus 6, which is 10, plus 5, so 15, which is D. Right, next one. Question 3. 5 grams of calcium carbonate, when heated, produce 2.4 grams of calcium oxide. Which is the correct expression for the percentage yield of calcium oxide? And then you get the relative molar masses and the reaction equation. So the, let's see, percentage yield, let's call it percentage yield. This is the experimental over theoretical. So we have the experimental mass, which is 2.4, because it's the mass we got from experiment. So we just need to find the theoretical. And judging from the equation, we see that for 1 mole of calcium carbonate, we get 1 mole of calcium oxide. So the amount of calcium oxide should be equal to the amount of, or the amount of moles of calcium oxide should be equal to the amount of moles of calcium carbonate. So let's find how many moles we have of calcium carbonate. And then to do this we use the equation N equals mass over molar mass, which is equal to 5 grams, because that's the mass, over the molar mass, which is 100. And then to find the mass of calcium oxide, we rearrange this to get M equals, or I can just, M equals N times big M, molar mass. And we have 5 over 100 moles times the molar mass, which is 56. So this is the theoretical mass we should get of calcium oxide, and then we put it into this equation. So experimental, let's just do this. Experimental is 2.4 over this one, and if we divide by a fraction, we flip the fraction, so we get 5 times 56 times 100, and if we want percentage, we have to multiply by 100 again. So we get this expression, which turns out to be B. Yeah. So B should be correct for this one. Next one, question 4. Which electronic transition would absorb the radiation of the shortest wavelength? So the keyword here is absorb, which means that we have to increase energy instead of decreasing, because that would release energy. And we see that the largest energy transition here is from 1 to 3, and we want the shortest wavelength, and we know that a short wavelength means higher energy, or rather a high frequency means high energy, and since a high frequency is the same as having a short wavelength would also mean high energy. So the answer here is B. Next one, question 5. Which is the electron configuration of the ion Fe2+. So we could start with finding electron configuration of Fe, which has 26 electrons. And you can find that from the periodic table. So if you don't know the order which you should fill the orbitals, you can just make one of these diagrams, which are important to know how to draw. Probably the most important diagram to draw for this electron configuration chapter. So we now draw the arrows to show the order, and then we start filling the orbitals. So an s orbital can contain 2 electrons, p can contain 6, and d can contain 10. So we start with filling in the order like this. Now we have 10, 18, 20, 26, like this. But we want Fe2+, which means that we have to remove 2 of the electrons. The electrons removed are from the outer shell, which in this case is the 4th shell. So we just remove this, and then we end up with this configuration, which turns out to be A. Alright, next one. Which element is in group 2? So group 2, let's say we have a nucleus here, and some inner shell, and 1 outer shell. And since it's group 2, it means that it has 2 electrons in the outer shell. So now we need to think about the energies needed to remove these electrons. Well, for the first one, it's not too bad to remove, because there's a lot of shielding from the inner shell, which means electron repulsion, which means that this isn't bound too closely to the nucleus, so it doesn't take too much energy to remove it. And it's the same for the second electron. Now for the third electron, which is in the inner shell, it takes much more energy to remove, because it's firstly closer to the nucleus, and there's less shielding. So it should increase from this one to this one, and it should increase a lot from the second ionization energy to the third ionization energy. And if you look at the options, this one seems to have the largest jump from the second to the third. So B should be the correct answer. Alright, question number 7. Which element is in the F block of the periodic table? So we can go to our periodic table and find the F block, which is this part. And then we just need to find an element which is in the F block, which in this case is B. And we can double check. C, which I believe is cerium, is here, which is in the F block. So the answer for 7 is B. And you could find this by just going back and forth from the periodic table and finding where these elements are. Right, next question, question 8. Which property increases down group 1 of the periodic table? Okay, so a group in the periodic table is like this, and we want to go down the group. So, and it's group 1, so it's metals, except hydrogen, but just ignore that. Melting point. Well, melting point is determined by the attraction between the particles. And since we're all in group 1, it means that all the metals can dissociate 1 electron. But as we go down the group, the nucleus gets more positively charged because we have more protons, which means that there's a larger repulsion between the positive nucleuses or nuclei, which means that the melting point would actually be lower because there's more repulsion, which means weaker bonds. Oops. Yeah, so it's not A because this would decrease instead of increase. And let's check B, first ionization energy. Well, since we're in group 1, there should just be 1 electron in the outer shell. But as we go down, there are more shells for each period we go down. So for this first one, the electron is in the first shell, and then the second shell and third shell, which means that it's further and further away from the nucleus, which means that you need less energy when you go down the group, which means that it's also not B, because this also decreases instead of increases. The next one, however, atomic radius. As previously mentioned, when you go down, you go up in how many shells there are. So when you go down, the radius does increase, which makes it C. Okay, question 9. What is the overall charge of the complex ion formed by iron 2 and 6 cyanide ions? So this is pretty simple. Fe2 plus and 6 cyanide minus. So if we just add the charges, 2 minus 6 is minus 4. So it's B, 4 minus. Okay, question number 10. Which statement about transition metal complex ions is correct? So A, the difference in energy of the d orbitals is independent of the oxidation state of the metal. Well, this is not true because if you have a more positive charge for the metal, you have a stronger attraction, which would split the d orbital even more, I think. Yeah. And B, the color of the complex is caused by light emitted when electron falls back from a higher to a lower energy level. This is also not the case because the color happens when light is absorbed, not emitted. So this is also not correct. C, the color of the complex is the color of the light absorbed when an electron moves from a lower to a higher energy level. Well, this is also not correct because it's the complementary color of the light absorbed actually. Because if you have, let's say, a complex ion here and then light is shined on it, then everything would be reflected except the color which is absorbed. So you'd see the color which is complementary to the one absorbed. So this one is also not correct, which leaves D, which is the difference in energy of the d orbitals depends on the nature of the ligand, which is true, because different ligands have different properties and attractions to the central metal, which would give it different d orbital splitting, which means that the difference in energy of the d orbital would depend on the nature of the ligand. Okay, question 11. Which is the best description of ionic bonding? So ionic bonding is when you have, for example, sodium chloride, where you have electrostatic attraction. So quite simple, it says already here, electrostatic attraction between oppositely charged ions. So it's 11A. Next one. 12. Which intermolecular forces are covered by the term van der Waals? So van der Waals covers basically all the weak forces, which are not covalent or ionic, which in this case is London dispersion forces, dipole-induced dipole forces, and dipole-dipole forces, which is 1, 2, 3, which is D. Okay, next one. Which bond is the least polar? So this is basically looking at the differences in electronegativity. So this one is a C to C, and then it is a C to O, and then we have a C to H, C to Cl, and N to H. It says bond, so the total molecule doesn't really matter too much. We know that, we can first see that these are all carbon. So the differences in electronegativity would just depend on what is bonded to. In this case, we have oxygen here, chlorine here, which both are quite electronegative, so the difference would be quite large, which means that they are pretty polar. So now we're just left with these two, and we know that nitrogen is also more electronegative, which makes C to H the least polar, because the difference in electronegativity is the least. So it's B. Okay, number 14. Which pair of compounds contains 9 sigma and 2 pi bonds in each molecule? So here we have a few molecules, and I think it's the simplest to draw them out to see how many or what kind of bonds they have. So in this case, this is a ketone. No, this is not a ketone, this is a carboxylic acid actually, because you have the C here, and then a double bonded O and OH, and then the methyl group here. So we want 2 pi bonds, and here we see that they're just 1 pi bond. So it's definitely not this one. Then we go to B. This one is a ketone, which looks like this. Methyl. For CH, okay, I can just write methyl equals CH3. Again, we have just 1 pi bond, so it's not B either. So now we go to C, which is CH to C, which indicates a triple bond, like this, and to another C. Oh, whoops. C. And then another C. So this would be the CH3 and this would be the CH2. So now we see that we actually have 2 pi bonds, because the triple bond has 1 sigma and 2 pi. So we have 2 pi here. And let's count the sigma bonds. We got 1 here, 2, 3, 4, 5, 6, 7, 8, 9. So this one does have the correct amount of bonds. So we could check the other molecule just to make sure, or we could just go to the next one to see if this one corresponds, and it seems like it doesn't, because we have a aldehyde here with a C double bond O and the aldehyde group here and the methyl here, which just has 1 pi bond, so it can't be this one, so it has to be C. Okay. 15. Which molecule contains an atom with sp2 hybridization? Well, for a carbon, sp2 means that it has 1 double bond, or that it's bonded to 3 different groups. This one seems like a straight chain carbon, which means that it only has sp3, so it's not this one. The same is the case here. There is actually a C to N, but C to N is a triple bond, so this is sp, not sp2, so it's not B. C also seems to be a straight chain, so it only has sp3, so it's not C. And D seems to actually have a double bond here, and we could draw out the structure, even though I don't have a lot of space. Yeah. Okay, so CH3, CH2, CH, 1 carbon, 2 carbon, 3 carbon, so this is double bond. And then like this, I think 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, that's not correct. Like this. Yeah. So here, these carbons are sp2, so it's D. Okay. Next one. 16. When 0.46 grams of ethanol is burned under a water-filled calorimeter, the temperature of 500 grams of water is raised by 3 Kelvin. And then molar mass and specific heat capacity of water, and you also get the equation. So we want what is the expression of the enthalpy of combustion in kilojoules per mole, so pay attention to the unit. So let's use the equation. Q equals mc delta T, where C is the heat capacity. So the energy released here is the mass of water, because we're measuring the temperature of water. So 500 grams times the heat capacity, which is stated here, times the change in temperature, which is 3 Kelvin. And when it comes to changes in temperature, it doesn't matter if it's Kelvin or Celsius, because they are the same when it comes to changes. Okay, so we have the heat, and now we want the heat per mole, so we divide this by mole, and we once again use the moles equals mass over mole mass, which means that the moles is the mass of ethanol, because that's what we're combusting, divided by molar mass of ethanol, which is 46. And also, by the way, if you get a molar mass or some kind of value in the question, it probably means that you're going to use it somehow. So now we know that we've used it, which is probably correct. Okay, so now we want to divide the heat by the moles. So we get 500 times 4.18 times 3 divided by this, which is a fraction, so we flip the fraction. And now we get this, but we want it in kilojoules per mole, and right now we have joules. So to get kilojoules, we just divide by 1000, because the way I usually think about this is that a lot of joules is less kilojoules, which means that you have to divide instead of multiply. So this is the expression we get, which turns out to be, oh, of course it's negative because it's combustion, it releases energy, so it's exothermic, which makes it negative. But all the answers are actually negative, so it's fine. Well, let's see, we get C as the correct answer. Okay. Number 17. Given the following information, what is the standard enthalpy of formation of methane? So for standard formation, we want to have it in this form, where the methane molecule is built from its constituent atoms. And this is basically just an application of Hess's law, which states that the path is the enthalpy is independent of the path. So we want to rearrange these equations to make this true, and I think I have to do it here because I don't have a lot of space. So we do want carbon on the reactant side, so this one seems to be okay. And let's see, with the last one, we want methane on the product side, so we can just flip this one. So we write the products on the reactant side. A bit cramped. That's fine. Now we want to cancel out the CO2. So how do we do that? Okay, it's cancelled out here. So we actually want to cancel out water. So we have 2 water here, which we need to cancel out because it's not in the equation. And we can get that by multiplying this equation by 2. So we get 2H2 plus O2 goes to 2H2O. So now we can start cancelling. 2 water here and 2 water here cancels. We have 2 oxygen here and also 2 oxygen here, which cancels. And the CO2 here cancels with this CO2. So we're just left with C plus 2H2 goes to CH4, which is methane, which is what we wanted. So now we need to figure out what we did. Well, we left the first one unchanged, so it's just E. The second one we multiplied by 2, so plus 2F. And the third one we flipped, which means that we put a minus sign on the enthalpy. So this one turns out to be D, which should be correct. Okay, next one, 18. Which combination has the most endothermic lattice enthalpy? So we get the radius of the positive ion, radius of the negative ion, and charge on the positive and negative ions. So if you want the strongest attraction, which gives the most endothermic lattice enthalpy, because you need the most energy to break it. If you want the strongest attraction, you need the larger charges, or the largest charges, which must be A or D, because they have 2, while these ones have 1, so it's probably not these ones. And then we look at what's different with A and B. So it seems like the radius of the positive ion is the same, and the charges are the same, so it only depends on the radius. And we know that a smaller radius means a larger or a higher electronegativity, which makes D the correct answer, because this one is smaller than this one. Okay. Question 19. In which reaction is the value of the change in entropy positive? So entropy is kind of a measure of disorder. So we want a reaction where the change of the disorder is the greatest. And a positive entropy comes either from increasing particles, for example, going from 1 particle to 2 particles, or a change of state, for example, going from a solid to a gas, because a solid is much more ordered than a gas. So let's check option A. Well, we see that it goes from 1 particle to 2 particles, and also it goes from a solid to a solid and a gas. So this one definitely has a positive entropy. So you don't really need to check the other ones, but we can, just to make sure. So this one goes from a gas to solid, which is a decrease in disorder, which is a decrease in entropy, so it's negative. And here we go from 3 particles to 3 particles, but we go from 2 aqueous to a aqueous solid, which is also a decrease in entropy. And here we go from 5 particles to 4 particles, which is a decrease, and we go from solid gas to a solid gas. Okay, so the states are unchanged, but we go from 5 particles to 4 particles, so this is also a decrease. So A is indeed correct. Alright, next one, question 20. Which graph shows the Maxwell-Boltzmann energy distribution of the same amount of a gas at 2 temperatures, where T2 is greater than T1? So this is pretty important. T2 is greater than T1. So this is the kinetic energy, and this is the fraction of particles with the amount of kinetic energy. So the more particles with higher kinetic energy means a higher temperature. So we want the graph of T2 to be shifted more towards the right than T1, which makes B wrong, and D might be correct, and A and C might also be correct because T2 is more to the right, but it says that we want the same amount of gas, so the areas under the graphs should be the same, which makes D wrong and A wrong, so it should be C. Alright, next one, question number 21. Which changes increase the rate of this reaction? Other conditions remaining constant. And then you get a reaction, which is mostly unimportant, because these are the important parts. So number 1, using larger lumps of calcium carbonate. Well, that would decrease the surface area which reactions occur on, which makes this one false because it would slow down the rate, and you want an increase in rate. Okay, next one, increasing the temperature of the reaction mixture. Well, this would increase the rate because the particles get more kinetic energy, which makes the probability of overcoming the activation energy higher, which increases the rate. And number 3, well, once again, if you have one correct and one wrong, you can figure out which is the correct one because it's either 2 or 3. So we know that 3 is correct, but we can still double check. It says increasing the concentration of hydrochloric acid. We see that we have hydrochloric acid here. And by increasing the hydrochloric acid, you get more particles of hydrochloric acid, which makes the probability of collisions higher, which also increases the rate. So it's 2 and 3, which is C. Okay, next one. Number 22. The rate information below was obtained for the following reaction at a constant temperature. Then you get the reaction. What is the overall order of the reaction? So rate equals K and then concentrations. Let's see what's done here. This is the initial data, I guess. And then this is the second. And we see that these ones remain constant, but the initial hydrogen peroxide is doubled. And when this is doubled, we see that the rate is also doubled, which means that it's first order to hydrogen peroxide. Okay, let's go from the second to the third trial. And here we see that these two remains constant, but the concentration of the iodide ions is doubled. And we see that the rate also doubles from here to here, which means that it is also dependent linearly to iodide. And then for the last one, this is constant, this is changed, this is doubled, and this is constant. But we see that the rate is not changed, so it does not depend on the H plus concentration, which makes this the rate equation. And since it's dependent on 2 concentrations, it's second order, which is C. Okay, question number 23. Which reaction is most likely to be spontaneous? So, most likely to be spontaneous. Spontaneity comes from this equation. Delta G equals minus T, delta H minus T delta S. And when something is spontaneous, it means that the G is negative or less than 0. Right? So we want G to be negative, and this occurs by having a negative enthalpy and a positive entropy, because that would make delta G always negative, which technically makes it always spontaneous. So exothermic and increase, which is B. Okay. Question number 24. Which conditions give the greatest equilibrium yield of methanol? And then this is the equation we get. Now, the reaction, or the forward reaction, is exothermic because the enthalpy is negative, which means that it's exothermic to this direction. So if you decrease the temperature, it's gonna want to increase the temperature by going to the right. So we want a low temperature, low temp. And we also see that we have 2 particles here and 1 particle here. So if you increase the pressure, it's gonna want to decrease the pressure by Le Chatelier's principle, which means that it once again goes to the product, which we want because we want the greatest equilibrium yield. So high pressure. Low temp, high pressure, low temp, high pressure, which is A. Okay, question number 25. Which combination of temperature and equilibrium constant is most typical of a reaction going to completion? And then get this equation. Well, going to completion, you want the most spontaneous reaction, which means that you want the most negative G, which means that you want RT, L, and K to be as large as possible. So this is done by a large temperature and a large K. So high T and greater than 1 equilibrium constant. So 25A. Okay, 26. Which of the following is not amphiprotic? So amphiprotic means that it can both donate a proton and accept a proton. So this is the case for H2O, which is water, because water can be in either OH minus form or H3O plus form. So this is fine. Now this one can be in phosphate form or H2O3 minus. H2PO4 minus. So this is also fine. This one can be in H2PO4 minus or H3PO4. So this is also okay. So it's not A, B, or C. But the third one can only be in this form or H2O form. There's no such thing as a H4O2+. It just doesn't exist. Which makes D correct. Or at least don't think it exists. It might be. I'm very not sure. No, I don't think it's possible. Well, anyways, it's a correct answer because the other ones works. Right. Number 27. The pH of a solution changes from 3 to 5. What happens to the concentration of hydrogen ions? So 3 to 5 means more basic, which means a decrease in hydrogen ions. And since pH is logarithmic, we can actually write pH equals minus Lg of hydrogen ion concentration, which means that a change of 2 is the same as a factor of 100. And it decreases, so it's decreased by a factor of 100. So D is the correct answer. Question number 28. Which statement is correct about a Lewis base? So a Lewis base, well, the way I usually think about this is that if you have a complex ion with a metal central atom or central ion, and then you have some kind of ligand. The ligand here is the Lewis base, and it donates electrons and acts as a nucleophile. So A is correct. Okay, 29. Which mixture forms a buffer solution with the pH less than 7? So I would just go through all of the options. We have 50 square centimeter cubed, and the same here. So we have equal amounts of a strong acid and a weak base, which would not be a buffer because we have equal amounts, and it would be acid. Well, let me think about this one. Okay, what would happen here is that all of this would dissociate, which would not make it a buffer because you don't have something. You don't have a acid and a base in the solution, so it's not A. For B, we have 50 milliliters and 100 milliliters, and a strong acid and a weak base. So this could work. This one, 50, 100, weak acid, strong base, could also work. 50, 100, strong acid, weak base. So all of these could work, but we want a pH less than 7. And let's see what happens if we react these two. The hydrochloric acid would fully dissociate and protonate the base, and we have more base than acid, which means that we would have leftover base, which could dissociate water or pull hydrogen ions in, which would make this basic, which is not what we want. So it's not B. And the case is same here, because we have a strong acid and a weak base. And actually this one is a 2-protic one, so we would actually fully protonate this one, which would not make it a buffer even. So the only correct one is C, because we have a strong base here and a weak acid, so we would get in solution the acid and its conjugate base, and we would have some of the acid left, which could dissociate, which would make the pH less than 7, and we would have more of the acid left, because we only had half of the OH. So we turn half of the acid into the base, but we're still left with some acid which could dissociate and make the pH acidic. So that's the reasoning for 29. Okay, question number 30. The equations below represents reaction involved in the Winkler method for determining the concentration of dissolved oxygen in water. And then you get some equations. The question is, what is the amount in mole of thiosulfate ions needed to react with iodine formed by 1 mole of dissolved oxygen? So the way to go about this, we have 1 mole of oxygen would give us 2 moles of this. Well, and 2 moles of this reacts 1 to 1 in this reaction. So 2 moles would give 2 moles. So 2 moles, we have 2 moles of this. And this is also 1 to 1 with iodine. So we would have 2 iodine. So if we have 2 iodine, we need twice the amount of thiosulfate, which would give 4. So the answer here is C, 4. Okay, 31. What are the products when molten sodium chloride is electrolyzed? So the keyword here is really molten, which means that we don't need to consider water in the solution in the redox processes. And we also need to know that oxidation happens at anode. The ions we have here are sodium plus and chloride minus, and this one oxidizes, this one reduces, and it oxidizes into Cl2, and this one reduces into Na solid. So at the anode, where oxidation happens, we get chlorine, and at the cathode we get sodium. So it's 31B. Okay, 32. Reduction potential values for some half equations are given below. Which reaction is spontaneous under standard conditions? Alright, the equation for E cell is the reduction minus the oxidation. And if you want it to be spontaneous, E cell must be positive. So let's see. The iron here is reduced, red, and the metal, the manganese, is oxidized. So reduction minus ox, reduction is this one, so minus 0.45, and this is ox, minus minus, which becomes plus 1.18, which is a positive number, so A is spontaneous. And you can check the other ones as well, but they're gonna be negative. Yeah. Okay, next question. Question number 33. 50 ml of 0.5 molar aqueous copper sulfate is electrolyzed using a current of 0.5 amps for 30 minutes. What mass of copper in grams is deposited on the cathode? And then you get molar mass and Faraday's constant. So the equation here you need to know is that current equals charge per time, which we arrange into charge equals current times time. And we should also know that Faraday's constant is the charge per mole of electrons. Okay, so let's find the charge first. By the way, T is in seconds. So charge equals current times times in second. So 0.5 current times 30 minutes times 60 to make it into seconds. So this is the charge we have. And now we want how many moles of electrons we have available. So we divide this by Faraday's constant, because now the units cancels into just moles of electrons, which we can double check. We're dividing coulombs, or charge, by charge per mole of electrons. And if we flip the fraction now, the charges cancel, and we just get moles of electrons. So this is how many moles of electrons we have available, but copper is in copper 2 sulfate form, so we need 2 electrons to reduce 1 copper. So we have half the copper of we have half the amount of copper as we have electrons. So we need to divide it by 2 again. So this is moles of copper sulfate, and now we use the last equation, which is N equals mass times, or mass over molar mass. And if we rearrange, we get mass equals moles times molar mass. So we have moles, and if we want mass, we just need to time it by molar mass, which is 64. So the answer here should be C. Okay. Next question. 34, which is propyl propanoate. So the anoate part indicates an ester, and esters are in the form COO with R here and R here. Yeah. So this one has a COO, this one has as well, but these two don't. So it can't be these two. And it says propyl propanoate, which means that this has to be propyl and this has to be propyl. So here we see that we have 3 carbons here and 3 carbons here. Well, here we have 3 and 2. So here we have propyl and the ester, which makes A correct. Okay. Next, question number 35. Which could form an addition polymer? So addition polymers usually has a double bond of some kind. So now we go through the options to see which one has a double bond. The first one seems to indeed have a double bond here, pretty sure, but we can check the other ones as well. This one seems to be a carboxylic acid on this side. Whoops. Carboxylic acid here. And this seems to be a straight chain. So it doesn't have a double C to C bond, which is required. It does have a double bond, but it's a C to C bond we want. In this case we have the same, where we have a carboxylic acid and a straight chain. And here we just have a straight chain with 2 amides on the side. So this one seems to be the only one with the double bond. So it's A. Just 4 questions left. Number 36. Which benzene derivative can be formed from methyl benzene by electrophilic substitution? Okay, so when it comes to drawing reactions, I actually like to draw out the double bonds, or localize double bonds, because I think it's just easier to visualize. So we have methyl benzene, which is like this. Now we need to see what has happened with the methyl benzene. First of all, this one is not even a benzene, so we can just cancel it out. It's a cyclohexane with a methyl group in what's called a chair position. But it's not a benzene, so it's not B. So let's look at A. A is not an electrophilic substitution, it's actually a nucleophilic substitution because the nucleophile here is Cl, chlorine, which has substituted a H. So this is nucleophilic, not electrophilic. And the same is here with the amine instead. So these are both nucleophilic, which makes this the only electrophilic. And I believe that the reaction here is that you actually have a NO2 plus from the nitration. And this one gets attacked from the electrophile there. No, the nucleophile there. And this would be the electrophile. So this would be a electrophilic substitution, which would give this product. Okay, 37. Which compound has two enantiomeric forms? So enantiomers means that it's chiral, it has two versions of the chiral molecule, and for something to be chiral, the carbon must have 4 different constituents. So let's check the first one. It seems to have a carbon chain like this with a central carbon and Br2. So we already know that it's not this one because the central carbon here has 2 Brs, which are the same, so it doesn't have 4 different ones. So let's go to B. This is probably the central carbon, and it has a chain here, a hydrogen, Br, and a metal. So this one does have 4, so it's probably B, but we can check the other ones as well. This one has a chain here, 2 hydrogens, which are identical, which does make it 4 different ones, so it's not C. And for this one, it has a chain here, hydrogen, Br, and a chain here, but these chains are identical, so it's not D as well. So it must be B. Next, we get a graph. Which combination in the table correctly states the value and units of the gradient? So the gradient equals the change in y over the change in x. So let's just do that first. The change in y is 3 minus, I guess, 0.6. So 3.9 minus 0.6, and the prefix here is 10 minus 3. This is the change in y, change in x, 0.05 minus 0.01. So this should be the value. And for the units, it's the same. It's y over x. So unit here is mole per decimeter cube per second. And the unit here is mole decimeter per decimeter cube. So moles cancel out, this one cancels out, we're just left with per second. So units is per second, and the value is this one. So it's A. Okay, 2 questions left. Which technique involves the absorption of radiation by bonds between atoms? Okay, HNMR. No, it's magnetic effect. It's nuclear magnetic resonance. It's not. It doesn't absorb radiation. What happens in NMR is that you have particles with spins, and then you knock out the spins and you see the difference between the energy levels with a spin towards, and basically the amount of energy you need to restore the spin or something. It doesn't have anything with absorption to do. Next one, infrared spectroscopy. This one indeed has something to do with bonds. It absorbs energy, and then it measures how much energy is absorbed. Yeah, not released. It measures how much energy is absorbed, and you get a diagram where it peaks like down like this. So infrared makes sense. Yeah. Mass spectrometry measures mass, and X-ray crystallography measures diffraction patterns, which is also not absorption. So B is correct. Okay, last question, number 40. The graph shows the concentration of some pollutants in a city over a 24-hour period. Then you get this graph. The question is, which of the following could not be inferred from the graph? Okay, let's check the options. option A, hydrocarbons cause less harm to health than pan. Well, it doesn't seem like we can figure that out from the graph, but let's check the other ones. An increase in hydrocarbons is caused by the morning rush hour. Well, maybe. You see that there's a sharp increase here of hydrocarbons, and it happens around the morning from 7 to 9, which is the morning rush hour probably. So this one can be inferred. So it's not B. And C, pan concentration increases as the intensity of sunlight increases. Well, here we have the concentration of pan, and it does seem to have the same shape as how intensity of light would be. So this one seems to be inferable from graph, so it's not this one. And the last one, nitrogen dioxide production follows the production of nitrogen monoxide. And we see that there's a peak of dioxide. No, this one is dioxide. We have a peak of nitrogen dioxide following a peak of nitrogen monoxide. So this one could also be inferred. So the only one which cannot be inferred is A, which is the answer. So that's it. Went through a paper. I think some questions were a bit tricky. I think the most difficult, well, this one was pretty difficult, but the other ones are difficult ones are usually the one involving calculations. For example, this one and the one with the mass of copper at the cathode. That one is also a bit more difficult. Other ones can be figured out by basically just looking. For example, these types of questions. Let's see, this one can be figured out from just looking. So this one should be quicker. So you would maybe do it in a few seconds, at least under a minute, and then you add more time for the longer calculation questions. So I think it's mostly pretty doable. There were some tricky or trick questions. For example, this one where it says absorb instead of released. So just pay attention to the question. Yeah, and I think that's basically it. I apologize if something did not make too much sense because I was just explaining as I went, so I might have gone a bit too fast or jumped over some explanation. I will probably do a more detailed explanation of these questions if it's wanted, so just let me know in the comments or whatever. And then I'll see you in the next episode.